Okay, welcome to this YouTube channel. My name is Aaron, and this video will be talking about or will be solving a question that deals with the AES. So therefore, question target here is question 2. So the question reads: as Israel continues to fight Iran, the IDF commander needs to send a message: attack from front, to their soldiers using AES with the key of fighting is over. So therefore, so far what I've analyzed here, you have been given the message and also the key to use to encrypt the message. So therefore, we continue. So use the hex actual table provided to convert the message and the key to hexadecimal value. So therefore, I'll provide my own hex actual table here, because the one from the question here at the bottom is not that clear. So for the sake of it clarity, so that it can be very visible to everyone, I would use this one, the one that I've provided here, which is still, it uses those same values. If you want this same table to be provided in the subscription, in the description. Okay, so we continue. So therefore, since AES, which is it simply means advanced encryption standard, encryption standard. That's what AES stands for. So therefore, this one is a base 16. So therefore, it uses hexadecimal values to provide the security, or to hide the message in simpler terms. So therefore, AES is commonly used, or it's the most widely used encryption right now. So including Wi-Fi's, how passwords are being stored in etc., or like even exchanging of messages, how they are encrypted, they use AES. Most, not all, but I can say most. Okay, so therefore, without wasting time, so therefore, since it's base 16, therefore it has a table that is divided by rows and columns. So therefore, it has 4 rows and 4 columns. Okay, so therefore, when you multiply 4 times 4 gives us what? 16. That's how the table is divided. So therefore, we have an example which I can give is this 0 0 0 0 like this, 0 0 0 0 like this, 0 0 0 0 like this, 0 0 0 0 like this. Yeah. So this is an example of how the table looks like of AES, where the encryption takes place. Okay, so let's solve this first 5 marks here that we have been given. So using the actual table, convert the message. So our message is the message is attack from front. So we also need to pay attention to the casing here, either it's uppercase or lowercase, because each value it represents a different value, like it has a different value that is assigned to it. Let's say, for example, uppercase A is not same as lowercase a. Okay, I hope that makes it clear. So let's get back here to this one. So let's convert this into into the actual table, using the actual table. So therefore, we need to put it like this. That's the first thing that we need to do. So therefore, we'll have something like this here. So here I'll just say that this is the message here. So this is the message that we need to convert. So we have A T T A like this. So we have 1 2 3 4. We go down. So 1 2, then we have a space in between here, so which also spacing carries a different value. So space, we'll just leave it like that. Okay, let's just use tab. Okay, what can I? Okay, I'll use an equal sign to represent space. Then we have F R O M, then space again, which is an we said we are representing space with equal sign. So again you have F R O N, so which makes this the whole full table, which is something like this. We have four rows, 1 2 3 4, and 4 columns, 1 2 3 4. Okay. So having done this now, we'll get back now to the actual table here, which is this. So we'll see what is A represented with. A is represented with capital letter A is represented with 65. So therefore we have 65 here. Okay, like this, 65. I'll give you space, then small letter t or lowercase t, which is 116 here, as you can see. So here we write 116, again 116, then lowercase a, which is 97 here. So we put 97 like that. Then I get down lowercase c, which is 99. Okay, then k, lowercase k, which is 107. Okay, then you have space. Remember I said equal sign we are representing space, so which is 32 here. So put 32 here. Sorry, yeah, 32. Then you have f, lowercase f, which is 102. Okay, it's 102. Then we have r, lowercase r, which is 114, 114. Okay, then what other value do we have? O, lowercase o, which is 111, 111. Then lowercase m, which is 109, like that. Then you have space again, which is 2. Then you get down, then lowercase f, which is 102. Then lowercase r, which is 114. Then lowercase o, which is 111. Then lowercase n, which is 110. Then remember, this was, we have converted this. Then we also need what? When this way, this message is not full. Remember we have t here. So for this one, for the t, we'll create another table that will represent that one. So we just say t, since t is the only one which, when we want to create another table, since it's on 16, so meaning we have to create another table of 16. So t will go with it, just zeros. T 1, so 0 0 0, just to fill up 0 0 0 0, just like that. 0 0 0 0 0 0 0 0, like that. And also convert it. So t will have what's the lowercase t, 116. So we have 116 there, and then 0. Okay. Okay, here as you can see, 48. So this one have 48, 48, 48, like that. So it will be just 48, 48, 48, 48, 48, 48, 48. Okay, so this is the presentation of how this one also be encrypted. So meaning the message that will be sent, there will be 2 messages that will be sent here. There will be this one and also this one, and they will be decrypted using 1 key. So therefore, this is how the message will look like when, so meaning you have converted the message as it was requested here. So what else do we need to convert? We need to convert also the key. So what was our key? So our key was fighting is over. So fighting is over. Okay, so this is the key. So we also do, so what we did for the message is the same thing that we need to do for the key. Remember, they're supposed to be 16. So the key, let's start with the key. So therefore we have something like, we have F E I G H T. Let's see, 1 2 3 4 5. Oh, okay. T I N G. Okay. I S. Oh, remember there is a space here. Fighting is, so here equal sign, like I said, representing space. So I S equal sign. Then we have O V E R. You see? So we also make this into the hexadecimal values, which is this. So get back to this again. I hope you understand why I said this is 3 marks. So we have 70 here, 70, which is capital letter F, which is in line to 70. I is 105. So let me just leave space for in case of 3 values. So 105 I, G 103, 103, H is 104. Okay, T is 116. K I 105 again. N is 110. G is 103. Then space is 32. Then I is 105, like that. Then S 115. Then space again, which is 32. O 111. V 118. E 101. Then R is what? R is 114. Okay, like that. So we have also converted the key into the hexadecimal. There you go, you have your free 5 marks. Okay, so let's continue. Question 3. Oh, question 2. So using the AES algorithm, encode the hexadecimal message in A above using range whatever algorithm with the round key in B. The S box and predefined matrix are given at the final stage. Okay, so one thing you need to understand is that the S box and the, what's the other one? What's the other? This is a predefined key. Yeah. So S box and the predefined key, they never change. They're the same. They're always the same. Okay, so you don't need to worry whether I use a different one. They're always the same. Okay, so first stage, we are now answering question B. Let me write question B here. Question B. So first thing that we need to do here is we need to do what is called the substitution. Substitution. How do you even spell this? Substitution. Yeah, substitution. So what are we doing really in substitution? So what we are really doing in substitution, we are getting these values and the exchange with the values that are corresponding with the S box. Okay, so the S box is just this, but since this is not visible enough here, this one here, and I've come up with it. I've downloaded this one online, which is very visible, this one at least. So I'm sure we have all done XY plane. That's mathematics that we used to do in grade 9, the issue of plotting, something like that. Yeah. So So here what we need to do, let's say for example we start with the A, this one which is 65. So we look 65 6. Remember the hexadecimal values, it says that they are 3 digits or 1 digit, right? 16 digit. Wait. Okay, just a minute. So let's say for example 65 here. Yeah, 65. So what do we do with 65 is oh, let me also, just in case, let me show you how to count this. So this is 0 1 2 3. So A represents 10. This is 11, 12, 13, 14, 15. Okay, similar way, this is 10, 11, 12, 13, 14, 15. Remember these values, they start from 0. So from 0 to 15 we have how many numbers? 16. Okay, so let's start with this. So what we do is, if there are two values like this one, there we have 65 here, so you split it. So this one will get the one that goes down, then this 5 will get the values on the upper ones which are going this side. So 5 will get those values that are going this side, then 6 will get the values that are going down like this. Okay, I hope I've made that clear. So 6, so get 6, you start with 6, so 6 is here, so go in line with where there is 5. Where is 5? 5 is here, so our value that we are picking is this one here. So we are creating what is called as a new state array. New state array. It's called a new state array because we are creating something new now that is unique, that is different from what we got. So therefore, the value, let me do that. Yeah, the value is 4D. So here we replace with 4D like this. So get another value like that, which is 116. Get 116. So yeah, I know you might be wondering why do we have like those two numbers like that. Well, here you only have numbers up to 15, up to 15, but here you have 116. So what do you do? You split it here. So we have 11 and 6. Okay, so 11 is here. A, B. So 11 is this. Then we have 6 on the right side. So therefore we have, so 11, so 0 1 2 3 4 5 6. Therefore we have this value which is 4A. So we put 4A like this. Okay, we go to the next one. We have 116 again, so meaning it is just repeating, so meaning we just put 4A again and it overs again. So we have 97, which is 97 there. So 9 is here. So 0 1 2 3 4 5 6 7, which is 8. So we put 8 here. So go to the bottom one, which is this one, which is 99. So 99, 0 1 2 3 4 5 6 7 8 9, which is EE like that. Okay, let me just, I'll just want to, okay, let me fill it up for now. Okay, so I don't want to make this video long. 107, like I said, since it's 107, so we pick 10 and 7. So 10, so 10 is A, and then you have a 7 there. So we have 0 1 2 3 4 5 6 7 here. So 5C. So we have 5C. 5c. The next one is we have 32, so 3, so I have 3 here, so 0 1 2, which is 23. So we put 23 like that. Then we have what other value? 102, so 10 and 2, so 0 1 2, which is 3a. Then we have 114, so which is 11 and 4. Where 11 is here, so 0 1 2 3 4, which is 8d. Yeah, 8d. So 11 1 11, so 1 and 11, so here 0 1, so c8. Then we have 109 10 and 9, so 0 1 2 3 4 5 6 7 8 9, which is d3. Okay, then we have 32. Yeah, 32, which is correspond with this one, to be 23. Yeah. Then we have 102. Did you have, okay, we had the 102 here, which is 88. See, yeah, so that you don't waste time. Oh, is it 88? Nope, not 88, but 3a. Okay, then we have 114. See, one we already solved for 114 here, so which is 8d space. Then we have 111 here, so we already solved 111, so which is this one here, which is c8. So that's how to save your time. Then we have 110. Oh, 11 and 0. 11. So 11 is here and the 0 is this one, which is e7. So have e7. Okay. Therefore, this is our new state tally. So we are done with it. This was again. Okay, we can just say maybe stage 1. Yeah, stage 1. Then we go to stage 2. Go to stage 2 now. So what are we doing here? Shift. You are shifting what? Shift. We say shift rows. How do you spell rows? Yeah, shift rows. Just forgotten the other name, or we call it. Yeah. Okay, shift rows. So what are we doing here is really simple. This one remains constant. Row 1 remains constant, so I'll just copy this and paste it here. It remains constant, doesn't change. Then this one will shift. Okay, we'll shift 1 to the right, 1 step. Each value shift 1 step. So meaning 3a will come here, EE will come here, 5c will come here, 23 will come here. Then this one will shift twice. Then this one will shift 3 times. Or we can say we can to shift 1 to the left. This one will do the opposite. So it's either you can consider shifting 3 times going to the right, or just shifting 1 time going to the left. Okay. 3 times to the right. Let me write start. Right. You know, there's always just one chap who can refuse to understand this and be like, oh, what was he saying? I didn't understand anything. Ugh. Yeah. Okay, like that. So I go to the second. So we get this one constant. say constant. This one doesn't change, it remains the same way the way it is. So we said this one step to the right, so therefore we have 3a here, okay, then EE, then 5C here, then 2 3 here, like that. Then this one shift twice, so meaning which one will be the first one here? D3. So D3 here, oh, is it D3? Yeah, D3 here, then 2 3, then 8D, then C8. Okay, this one twice, 1 2, so it comes here, this one comes here, and this one 1 2 comes, so D3 here, and 2 3 here. Okay, great. Then I like using this one though. I just think of one step to the left. So this meaning 8D here, C8 here, E7 here, then 3A here. So it is still be the same. So 3 steps to the right, one. So this one move here, then up to here, and this one move here, then up to here. You see? And I say 1 step to the left. Okay, so we are done with this stage. Now this one is really easy. This is the simplest one. So here comes now stage 3. So stage 3 here, what we are doing is so keep in mind of these stages. Keep them in mind. Don't forget. So here we have stage 3. So stage 3, we have here what is called the mixing column. So what are we doing here in mixed column? So in mixed column, what we are doing is we are multiplying this times let me go back to the equation. You are multiplying with what? The predefined key. Okay, so this is also a new state array. So new state array is just whenever we're making changes, meaning everything changes. It's called the new state array. New state array. So I've created another one. This one is not the same as this one. Okay, so here so at mixed column again, let me say it like this. So here what we are really doing here is we are multiplying new state array. Okay, let me say mixed, yeah, mixed it state array, so meaning this one here by predefine the key. Okay, that's what we want to do now here. So I will just solve one column. Yes, that's what I think, that's what is necessary to my, so that the video doesn't take long. I'll just solve one column, then you finish up the others. Yes, provided you understand everything that we are doing, you'll be able to complete it. So therefore let me copy this. So we define the key this side, we define the key multiplied by mixed column. Mixed state array. Okay, so therefore this one just 0 2 0 3 0 1 0 1, and it goes back here. I just which one? I just pasted this in advance. Oh yeah, I knew it. Something like this will happen. So 02 02 03 01 01. Remember what I said, the state tally doesn't change. Oh, the prevent key doesn't change. So here you have 01 02 03 01. Okay, then here you have 01 01 02 03. Okay, then here you have 03 01 01 02. Okay, so that's what we want to do here. So another thing we need to introduce is whenever you are multiplying with 1, if the key, okay, the values from the defined key, if it's 1, let's say for example this one 01, 1 is just 1 itself. If it's 2, we say x plus 1. Okay, if it's 3, we say, oh sorry, just x. If it's 2, just x. Then if it's 3, it's x plus 1. Okay, I hope you did binary. Something like that. Yeah, some knowledge from binary here to help, but I will make it simple as possible. Okay, so this is what you need to put in mind. So when you are using this, let's say for example, when you're using this, just know that what you're supposed to use is this. When you're using this, you're not supposed to use this. When you're using 1, it's just 1. Okay, so we continue. So the first one is 2 by 4D. Okay, so how do we do that? First of all, we need to convert this into binary. Okay, so we split it. When converting a hexadecimal into binary, we just split it in between, then you have something like, so binaries they are like this. So our values like 21 28 64 32 32 16 8 4 2 and 1. Okay, so what we do now is we forget these big numbers and just repeat 8 4 2 1 like this. Okay, that's what I want you to think of. Why? So here, since we have 4D, remember, we also need to have that knowledge again. Where is it? Yeah, here, remember this. Okay, I showed it as a table. Remember these values here. I said A represents 10, B is 11, C is 13, D is 14. Oh no, A 10, B 11, C 12, D 13, E 14, F 15. Okay, so here we have a number which is 4. So from this side, remember, so we are splitting it, so just things like it's like this sign. Yeah, so from this side, which numbers can we use to make 4 here? We just need this 4 itself, isn't it? So therefore, these numbers that we don't need, that don't have, that cannot make 4, so we put a 0. Then we need 4, so well, with the value that we need to use, we put a 1. So since we need the 4 to, so that we can make the 4 there, so we put 1. We don't need 2, we don't need the 1 here. Okay, then we go to the other side. Remember I said D is what? D is in, D is 14, 13. So what numbers can we add here? Among these 5 numbers here, or 4 numbers here, which one can we add to make 15? So first of all, get 8. So 8 plus 4, 8 plus 4 gives us 12, plus 2 gives us 14. So you don't need the 1 at the end. So this 4D that you are seeing, this is how it appears in binary. Okay, I hope that makes things clear. So we also have now what do you call it? Okay, I've forgotten how we call this, but we have these numbers. Since remember, we have numbers starting from 1 up to 8. So here we start with the power 7. So x to the power 7, x to the power 7 plus, so we now get all the numbers, all the numbers below 8, all the numbers below 8. The number, no matter how much you can add it, should not exceed what? 8. Should not exceed 8. So have x to the power 6 here plus x. Okay, let me use a capital letter. Okay, like this. Then we have x to the power 5, like that, plus x to the power 4 plus x to the power 3, okay, plus x to the power 2 plus x itself, like any number that is power to 1, it is x itself, isn't it? It's the value itself, yeah, plus any number to the power to 0 is what? 1. I hope you get that concept here. Any number powered to 0 is what? 1. I'm sure I have done that in mathematics. What we call, is it indices? I don't know, in algebra or something. Yeah, if you can be able to remember that, then we are good. So any number powered, so here this is same as power 1 here, in case someone is getting confused. Then this is same as x to the power 0. So instead of us writing x to the power 0, you know that any number to the power to 0 is 1. Then any number to the power to 1 is the number itself, and we did this. Okay, so the next step is what you need to do here is you see this value that you have, this, after I've converted this into binary, we align it with this equation. So you always have, you should know this in your mind. Yeah, you should stick somewhere, like the same way you know your name. So we align with these values that we have here. So here the first one we have 0, 1, 0, okay, 0, 1, 1, 1, 0. Okay. So as you can see now what we have done here. So we want to get these values that we powered by x, this one, these x is with powers, that where the number that is in line with it, with these numbers in line with it, where there is a 1, not when there is a 0. Okay, so I know you may be wondering, but why are these not, if you count these again, there are 8 here. 1, 2, 3, 4, 5, 6, 7, 8. So and they are not exceeding that. Okay, so according to this one, so we are getting only those values where there is a 1 at the bottom. So we have x to the power 6 here, x to the power 6 plus we have x to the power 3 plus x to the power 2 plus x itself. Okay, so so now what we are doing is we are getting this value now that we have gotten here, and multiplying it to the value here. So it's easy, row by column, row by column. I'm sure you know how to multiply matrices. If you don't know how to multiply matrices, find the video so that you learn how to multiply matrices. Because I think to make our video long here, start doing that. So row by column. So in simple terms, this one multiplied by this one multiplied by this one multiplied by this one multiplied by this, to find the value that would replace this. Yeah, I feel you. I feel it to take time. Yeah, it always takes time. So here, after I have this now is remember we are multiplying 0 2 times 4d. So therefore I said when you are multiplying by 2 you present with what? X sign. So here it is like x multiplied by, so x multiplied by everything inside here. So x multiplied by this one. So since the bases are the same, we just add 1 to the power. So here we have x to the power 7, x to the power 7 plus, then here we have 4 x to the power 4. So x times this is giving us this. X multiplied by this is giving us this. Since the bases are the same, we just add the powers. So this is same as x to the power 1. So 1 plus 3, which is 4. Plus, let me be giving a space so that it's very clear and very visible. So to the power, so this one and this one will have x to the power 3 plus this by this to give us x to the power 2. Okay, so we get back to this again, where to this again here, so that we convert this into binary now. So what do we do here? According to this new equation that we have come up with now, this one here, we have to compare again in line with this. Do we have x to the power 7? Yes, we do. We put a 1. Do we have x to the power 6 here? We don't have. We put a 0. Do we have x to the power 5? We don't have. We put a 0. Do we have x to the power 4? Yes, we do. It's this one. So, sorry. We put a 1 here. Put a 1. Do you have x to the power 3? Yes, we do. It's here. So we put a 1. Do you have x to the power 2? Yes, we do. It's this one. We put a 1. Do you have x itself here? No, we don't. So we put a 0. Do you have 1 itself? No, we don't. So we put a 0. We put a 0. So that when you count this, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we convert this into there's a problem with this. This is very bulky. So let me just leave a big space here. So we convert this into hexadecimal back again. So remember what we did here when we are converting this into binary. We had to split in between, right? So we get also these same values and split them in between here. Okay, so we align it with it. We get back. Let me copy this. You need this back here again. Okay, something like this. Okay, so what do we have when we add this one and this? What do we so have, since we just only adding values where there is a 1, so we have 1 which is in line with 8 and 1 which is in line with 1 here, right? So 8 plus 1 giving us 9. Okay, then here we have 8 and 4. So 4 plus 8, that is 12. 12 which is C. So we have C. Here, C like this. So get this. So I'll just say, let me say new state array here. New state array. So I'm creating another array here. So we have solved one problem here. No, sorry, my bad. We haven't yet done anything yet. Okay. So we just leave these binaries. Okay, we are not converting here yet because we haven't yet Xcode. Haven't yet Xcode. Sorry. So we'll keep these values like this for future use because we remember this is a row by column. Like I said, so we have to oh shit. So, sorry for that. So remember what we want to do here is we are doing a row by column way. So we're multiplying this by this, this by this, this by this by this to find the value that will replace this sign. So what we have done, we have only done one for this one. So 2 times this. So we need to do for this one, which is this one, then also the rest, so that we can find the value that will be for this new state array here. So let me just empty record, so for 0 like this. But if you're using a pen, please don't do this, because me, I'll just erase the values here, and you. So that's what we need to fill up this box. It's the same process. So we have found one here. So next is this one. We have 3 by 3a. So this was for, let me write, this was for 4D. So I'll just write 4D here like this. Let me say solving, yeah, so that you can keep in track. Solving 4D. Okay, so we're done. So next is, what are we doing? Solving 3a. Solving 3a now here. So what do we need again? So we need this guy as usual to convert. Okay, so what do we have? We have 3a. 3a. So like this. So even here like this. So what numbers do we need to make 3 here from this side? We need the 2 and 3, right? Oh, 2 and 1, sorry. So therefore we just put a 0, this one 0, then 1, 1. Simple. Okay, let me not put this. Okay. What do we remember? A is what? 10. Maybe I also A equals to 10. Yeah, just in case there's someone there busy trying to memorize. So 11, C is 12, then D is 13, then E is 14, then F is 15. Great. So that we can just be looking at these values there, and again I go there, we check to the table there. So these are the values. So we have a which is 10, eh? So here, what values do we need to make 10? We need 8 and 2. So therefore put a 1 here, you don't need 4, but you need 2, like that. So this is how 10 appears in binary. Okay, so after having done this, you get this guy back. Yeah, let me copy it. Get this guy back here. We need you, something like this. So therefore again we align. I think I should have just copied this as well. Yeah, because this one is properly aligned. So we align. So this one with 0 here. So let me just replace the actual values. Now 1, another 1. Yeah, something like this. Okay, great. So like just like this previous way we did it. Yeah. So what do we need here? We are getting x5, x to the power 5, x to the power 5 plus x to the power 4 plus x to the power 3, right? Plus x. This one here, this one here, this one here, and this one here. So we have this guy here. Okay, so remember we are multiplying. Okay, so remember, so be putting this one, we are multiplying with 3, which is equals to x plus 1. That's what you are supposed to use. So this is just a reminder in case someone has forgotten. So here we are multiplying with just x here. Okay. Okay. Okay, yeah. So that's what we are using to multiply here. Next is what do we need? So since we have this now, next is we just say x plus 1, right? Open bracket. Okay, times open bracket. Then I just copy everything here and paste them here like this. So you know the way we do with multiplication when we are dealing with such stuff. So get x multiplied with everything, then we add, then we get this and multiply with everything as well. So let's start. So x, since all the bases here they have x, so let me just, so I'll just increase the power by 1. So here 5, here we have 4, then here we have power 2. I hope you understand what I've done. Since all the bases are the same, then this is assumed that there is power 1, so just add. So when the bases are the same, just add powers. So this would be 1 plus 5, 6, 1 plus 4, 1 plus 5, 6, 1 plus 4, 5, 1 plus 3, 4, 1 plus 1, 2. Then add again. Here we have, so since whenever I'm multiplying with 1, means you just repeat, everything just repeats the way it is, right? So I just put that back. Then now we have to cancel things that are like things that are repeating here. So for example, so what I'll be doing, I'll be putting this to show that we have cancelled. So do we have 6 here? Yes, we do. Another 6? Nope. So we write it down here. So we are removing the spectators. What do you call them? These guys were just watching, we are just repeating. So 6 to the x to the power 6 plus, we have 5 here and another 5 here. So this guy is eliminated. Okay, so it won't be considered. So we skip x to the power 4. We also have x to the power 4 here again, eliminated. X to the power 3. Okay, so and also please, when you are doing this, make sure they also follow in like, is it ascending order from the biggest to the smallest. Don't just randomly put them. So like this, then you have next is easy, x to the power 2 here, x to the power 2. Is it repeating anywhere? Nope. So it's x to the power 2 here plus x here, x. Okay, so since we have this now, we convert it into binary as well. We get back here. Do you have x to the power 7? Nope, we put a 0. Do you have x to the power 6? Yes, we do. Put a 1. Do you have x to the power 5? No, put a 0. X to the power 4? No, don't. We have a 0. X to the power 3? Yes, we do. Put a 1. X to the power 2? Yes, we do. Put a 1. X itself? Yes, we do. Put a 1. Do you have a 1 here? No, put a 0. Such that when you add this 1, 2, 2, 3, 4, 5, 6, 7, 8. Okay, meaning all is good. So let me just put a space here, space. Okay. Okay, so we are done solving for this one. Next is, so in this, the good part is, whenever you are just multiplying with 1, just convert this into binary. We are done. Okay, so we have the next value is D3. we have D3 here. So D3 is the one that you're supposed to solve next. So I'll write here solving D3. So as usual, do like that to separate it. Then this one you are multiplying with 1. Okay, so like I said, whenever you're multiplying with 1, just convert this into binary. You are done. You are done with it. You cannot go any further. Okay, just convert it into binary. You are done. So therefore, remember what I said. This one. So this is 13. So we just get this guy back here. That's what we need right now. Okay, so what number do we need to make 13 here? 8. Yes, 8 plus 4 giving us 12 plus 1 39. So here we have 1 1. We don't need a 2, so put a 0, then put a 1 here like this. Then we have 3 here. So what number do we need to make 3? We don't need 8, we don't need 4, but need 2 and 1. So we are done with this one. So how to say now? So solving what I my is still typing that way. Yeah, so we are solving now, which is 8D. So we say 8D as well. So as well multiplied with 1. So the only thing, so what we are doing here again, just converting it into binary. That's all. So here, because every value that we are getting, you're putting them like that. Yeah, something like this. Yeah. So what numbers do we need to make 8? Just need 8 itself. We don't need 4, we don't need 2, we don't need 1. Okay. Again, D, we need 8. Remember this 13. So we need 8, we need 4, we don't need 2, but we need 1. So 8 plus 4, 12 plus 1, 13. Okay. So we're done solving for this one as well. So next step is we need to add this. Actually not add, but XCOR. Yes, XCORing. So what XCORing does is okay, let's just do it. Yeah, let's just do it. So we start by, we get first these ones that we solved at first. If you remember, this was our first guy we solved. So I'll copy this. So here I'll say we are XCORing. That's what you're doing right now. So I'll put this, get back where was the other one. So we solved it for D. This was the final answer. This one here was the final answer as well. So I'll copy this and put it here. Then get this and put it here down. Yeah, and this as well. Okay. So what we are doing now, we are XCORing in. So what XCORing does is when there is in, okay, let's just do it. So it's like this. There's nothing like carry one here, so you can start from whenever I want to start from this side or start from this side. So 1 plus 1 plus 0, it's 1. Then 1 plus 1, it is 0. Then 0 plus 1, it is 1. Okay, we come to this. So let's just be ignoring the zeros. So 1 plus 1, yeah. Like remember what I said, 1 plus 1 is what? Okay. Let me write it here. 1 plus 1 equals to 0 every time when we're adding this, when we're scoring, sorry. So then 0 plus 1 equals to 1. So keep this in mind. Then 0 plus 0 equals to 0 again. So here 1 plus 1 0, 0 plus 0 there, just a 0. Then here 1 plus 1, 0. So this one 0. Then we have a 1 here because of even here 0, 0, 1. This is a 0. This is a 0 as well. Okay. So after I've done this now, the next thing we need to do is we convert this into hexadecimal value now. Yeah, so for the previous one what I did, yeah, so this is why now we convert this into hexadecimal. So we split it here again, the same way we're doing here. So what number is this? Okay, let me just copy it in case there's someone again who is copy. Okay, so let me get back these values like this. So have something like this, right? Then I'll copy this as well and put it here. So yeah, so we don't, where there are zeros we don't consider them. So we have 8 here, so 8. Then we put this. What number is this? 8 plus 4, which is 12, right? Yeah, which is C. I think. Yeah, C. Remember 12, 12, 12, 12, 12, 12 is C, yes. C. So how 86. So this is now what will be, what we replace here. Okay. Oof. I'm sure, yeah, I'm now getting bored now, but I hope you're understanding the logic here. But I want to solve this, that trick part that I want us to handle. So so the next one is, since we are done this one by everything here, we are found for this one. So for this one now is we are getting this row by this whole column. Again, to find for this one, we get this whole row by this column. Again, to find for this one here, we get this whole row by this whole column. And where I start from. I know you're complaining inside your chest. They're like, this is too much. This is too much. Yeah, this is more like this is just a bulky part about it, but this is really easy if you have understood everything that I've done so far. I'm sure I've gotten something. So let's deal with this one here. So we are going to solve for this one now. So remember, so we have only solved the 1 out of 16. So remember how many are remaining? We are remaining with 15. So we have solved one box. Okay, so let me write here again. Oh, you know, here we are solving box 1. Yeah. Okay, so I have solved the first box. So let's go to the second one now. Let me close it here in case I'm scrolling too fast, someone didn't see. Okay, these are all the calculations. So I only do 2 boxes. Yeah, then there's to do them on so that the video doesn't take long. Otherwise there's there's the 4 stages. So we're remaining to 1 stage coming ahead. So here now say solving box 2. Solving box 2. So what do we have here? Get back to this. Okay, let me copy it so I don't want to be filing this again, like scrolling up all over. This will be too much. So let me put them here. So we are solving box 2 now. So remember, we have solved already for this one. Okay, so we are starting with this one. So remember what I said, when you are multiplying it with 1, just convert that value that you are multiplying with into binary. That's what it says there. So solving, I'll say solving like the previous way. Solving it's 4D. Yeah, 4D with 1. We are multiplying it with 1 like that. So just like I said, let me copy this as well. Yeah, so what numbers do we need to make 4 here? We don't need 8, we need 4, we don't need 2, we don't need 1. Remember D is 14, oh 13. Yeah, so 8, 4, we don't need 2, but we need 1 like that. So this one we are done solving. This one we are done solving, just like this. The next one is in 2 by 3a. Okay, so solving 3a. So in case I make mistakes, you can correct me. Yeah, just hear what I'm talking about in case I make a mistake. Okay, so this is x. Remember 2 is presented as the x sign here. So I'll put this. So 3, what number do we need to make 3 here? We don't need 8, we don't need 4, we need 2 and 1. Remember a is 10, we need 8, we don't need 4, we need 2, we don't need 1. So 8 plus 2, which gives us what? 10. Great. We also need that guy, that's that long equation. Where is it? I don't know. I cannot still remember the name, how to call this. But if you are following along, doesn't matter if you, even though you don't know. What matters you being able to solve this. Yeah. So 0, we are aligning this with the equation. So 0, again 0, then we have 1, we have 1, we have 1 here, we have a 0 here, we have 1, we have a 0. So what we need here is we need x to the power 5 plus x to the power 4 plus x to the power 3 plus x. And the good part about this, I don't think so if you need the calculator. I don't know if you can, unless you cannot solve this to my minimal math problems here, but to my side, I don't think so. Someone might need the calculator for this. Remember, we are multiplying it to x, right? So this is the equation that we need. So we have x multiplied by, open bracket, is 14. Yeah. So like I said there again, same bases, just add powers. Therefore, we have x to the power 6 plus x to the power 5 plus x to the power 3 plus x to the power 2 to the power 2. Do you have any guys which are repeating here? No, we don't. So do we have x to the power 7 here? No, we don't. X to the power 6? Yes, we do. X to the power 5? X to the power 4? No. X to the power 3? Yes. X to the power 2? X itself? No. Then 1 itself? No. So we are done solving this one. Okay. So we solve another one again. We are now multiplying this one with 3D. Oh, so 3D by 3 here. 3D. Okay. So we have 3D. Is it 3D or D3? Which one? Oh, D3. Ah, D3. 3A. Okay. Okay. 3D. This one, like usual. Yeah. So, but don't put this, please. I'm just showing you for this to quick just separate them when converting into binary. So this one we are multiplying with x plus 1. So therefore we have we need this. Okay, what numbers do we need here to make 13? Okay, this 13, just confirm me. What numbers we need? 8, yes. We need 4. So 8 plus 4, 12. Don't need 2, but we need 1. So 8 plus 4, that's 12 plus 1, 13. So go next to 3. What numbers do we need? 3 to make 3? Don't need 8, don't need 4, we need 2 and 1. Okay. Bring back this equation here. Yeah. So we align again. So 1 over 1 here, 0 here, 1 here, 0 here, 0 here, 1, 1. Okay, beautiful. So what do we have here? So we have x to the power 7. Yeah. This is the question which I wanted. This. Yeah. So this one is the one which is most tricky. I'm sure you'll get where we're going. So we have x to the power 7, x to the power 6 plus x to the power 4 plus x plus 1. Okay, so remember when multiplying with what? X plus 1 here. So x plus 1 open bracket multiplying with everything here. So when bases are the same as usual, so how x, so x times this one, wow, x to the power 8 plus x by this one here, we have x to the power 7 plus x to the power, so x, so this one we have 5, then plus x to so this one be to the power 2, x, we have one x there. Okay, so since everything is being multiplied by one here, so just copy this plus here like this. So there's new power here. So all along we have been ending on power 7. Even looking at the equation, we don't have x to the power 8 here. So what do we do? Let me extend the screen here. Oh, we no longer need this now for now. So what do we do here is we break this into simpler ones. Like we cannot have to the power 8, because when you count numbers from 0, remember power 1 is out of 0, right? So from 0 to 7 you have how many numbers? 8. So when you have an 8 here like this, it means you have how many numbers? 9 in total. So what we do, we break this into into simpler numbers which are not exceeding what? 7. So how do we do that? So okay, I think that's always like that. Is done like this. Remember, there is a byte and a bit. Okay, so since this is almost like a byte, right? A bit. So I have to break it up into a bit. Okay, half of this. We just need half of this. But even though we break it into half of it, when we add those, they should be totaling up to 8. Okay, so what we do here, we'll get x to the power 4, right? We first get the number that can cut this into half, which is 4, right? So 4 plus, we cannot reuse this number, so we'll get another number here. So x to the power 3. So when you add 3, space here, I like putting the space here. Okay, like this. So 4 plus 3 gives us what? 7, right? Is it equal to this? No. We still need one more thing. Plus x. Remember, x is the same as what? Power 1. So this is same as to the power 1 like this. So when you add these powers, they should be equal to this same number here. So 4 plus 3, that's 7, plus 1, 8. And then remember, this is not a half a byte. So a byte is just a group of 8 bits. So 8 bits is equals to 1 byte. Okay. So half of a byte, that should be 4, right? Are these values here 4? No, they are not. So what do? We need to add a number that will not make any difference. So now we bring back what? 1. Remember, 1 is same as 2 power 0. This is same as 2 power. This is same as this is power 2 0 like this. So that when you add 4 plus 3, 7 plus 1, 8 plus 0, it is still what? 8. I hope you understand that. Then afterwards you bring these everything here. Bring them back here. You bring them back here. So I'll just copy and paste it here like this. Okay. And I was saying, like, yeah, I was really interested with this one because this one is a little bit tricky. Yeah. So once we have done that, now we start cancelling these guys who are repeating. So which one do we have? Okay, let's get to the bigger ones. X to the power 7, we have it here, and also x to the power 7 here. Okay, so meaning this is already out. X to the power 6. Okay, so we'll start with x to the power 6 here. We'll start with x to the power 6 plus, because 7 is repeating, and well, I cannot cancel here, like the issue of cancelling here, like erasing something. Okay, so this one is eliminated because it is repeating. Then we come back to 6. Do you have any value which is 6 here? No. So we get it. We come to 5. We come to 5. We'll be reducing up to 1. Do you have any other 5 here? Any other 5? another 5. No, we don't. So we include it. X to the power 5 plus, do you have, so we get to 4. So do you have any 4 here? So have this one here and this one here. So we cancel it. So it's x. Oh, so 4 won't be included. We get to 3. So have we 3 here? Another 3? No. So we just put x to the power 3 plus. But let's say for in a situation where I have 4x, they are repeating 3 times. So meaning we include it. Unless if it's just repeating twice. That's a trick part there again. So have let's say 4x plus 4x plus 4x. Yes, we include it. Unless if it is it even numbers that are divisible by 2? Yes, the same way we're doing with the scoring there. When you're adding 3 numbers, 3 ones, meaning you will get a 1. But if there are 2, it's a 0. Okay, so 2, we have a 2 here, another 2. Confirm, no, another 2. So x to the power 2, x to the power 2 plus. Okay, let me remove now this. This was just for formality. So have x x x. We include it. I hope you understand what I'm talking about, what I meant now. If they are repeating 3 times, so include it. Next is we have 2. Oh, we have okay, I've already got it. We have 1. So 1 is here. So 1 is repeating twice. So here and here. So we don't include it. We just leave it like that. Okay. Then we convert this back into binary. So do you have x to the power 7 here? No. X to the power 6? Yes. X to the power 5? Yes. X to the power 4? No. X to the power 3? Yes. X to the power 2? Yes. X itself? Yes. 1? No. Put a 0. Okay. What other value haven't we solved? So we are solving the, so since this will be multiplied by 1, so we just convert this into binary. So 8d. So here say solving 8d. This is being multiplied by 1. So like I said earlier, when you are multiplying by 1, just convert it into binary. It ends there. Oh, whatever I done. Okay. So what number do we need to make 8 here? We need 8 itself. 4, no. 3, 2, no. 1, no. Okay, D, remember D is 13. 4, 8, yes. 4, yes. Making 12, we don't need a 2, but we need a 1. So it ends there. But on this one, let me make an emphasis. Remember we had the 3x here, x. If they say no, your calculations are wrong here, then just eliminate all the x's here. But it should be included since it's repeating 3 times. Unless if it was repeating 4 times again, the number itself it is repeating. If it's divisible by 2, it's a 0. If it's not divisible by 2, you get it. So after, so we have this now. What do we do next is we exclude. So like you say, we are scoring. So let's get these values. First of all, we started with this, so copy this here. Okay, next is in next was this one. Okay, and the other one is this one here. Then the last one is this one. Okay, remember those rules which I said when we are scoring. So this one 0 0 0 plus 1 is a 1. This one 0. So since there are 3, this one, this, when we add up, this is not divisible by 2, so it's a 1. This is divisible by 2, so it's a 0. 0 divisible by 2, so it's a 0. Divisible by 2, it's a 0. Not divisible by 2, so it's a 1. Divisible by 2, it's a 0. Okay, so we convert this into hexadecimal like that. Oh, where is it? We need this. Copy. This final answer. Okay, so what number do we have here? So we have 8 plus 4, which is giving us 12, 12 which is C. Then here, this side just have a 2, so C2. So therefore, for this value here, we put in C2. So we keep on replacing these values until this is all filled up. So what do we do now? Like since now what we have done so far, to be just the repetition of everything, to be just repeating, to be just repeating, to be just repeating. So let me just go to the other stage, which you say stage 4. So yeah, okay, let's just go to stage 4. So this one is called the add the round key. Okay, so in stage 4 we are just adding the round key. So anyone might be wondering where is the round key. So the round key, it was that key that we are given at the beginning. Remember, we had the message which was attack from front, and also fighting is over, which was the key. So we'll get these values here. I'll just copy this like this, take it down here. So what we are really doing here is even though it said we are excluding, actually, yeah, this is okay, I don't know, but it somehow said round key. We are excluding round key and the new state array, new state array, yes, new state array, with this state array that we are from creating. Oh my goodness, so I just have to go and copy that. Where is it? This was not supposed to be shifted, mixed, but shifted. Sorry, shifted. Yeah, shifted is state array. So where is the key? The key is this one here. So copy this. So this plus this here, this new state array. So this new state array is from, and okay, now okay, this is the mixed state array. Okay. Okay. So how 8C. Okay, then I just want to write this part. So this is the round. This is called the round key. This is the round key here. This is the round key. Then this is the mixed or mixed state array, okay. So okay, I'll just put zeros. What if I pressed? I'll just put zeros since we haven't yet solved everything here, so I'll just put zeros like that. So 0 0 0 like that, yeah. Then here remember we found C2 0 0 0. So these other ones are remaining, you can fill them up on yourself. Yeah, all I wanted was you to get the concept here. It is what is really important to understand what is happening, not me completing this whole solving. Yes, pardon me or not finishing up this, because the video will take more than 2 hours just to finish up here. So so to add up this, we'll get this data, this one, we'll convert this into binary. Okay, so okay, where is that table? I like this. So since these are still hexadecimal values, so we're still using the same one. So remember here we're converting what? 17. We're converting 70. Someone may be confused. Emissaries. So hex to bin. So bin binary, hexadecimal. So 70. So what numbers do we need to make 70 side? We don't need 8. We need 4. Yeah, 4, yes. 2, 6, 7, eh? Then 0. We don't need any of these. Just like that. So I've converted 17 to binary. Okay. Then we also need to convert 8C into binary as well. So I'll just write it from here, 8C. Okay, let me put the same thing which I was putting here, so that every time whenever you're converting this, you need just to keep in mind that you just split these two guys. Okay. So what values do you need to make 8 here? We need 8 self 1, so the rest is just don't need them. C is 12, so what numbers do we need to make 12? We need 8 and 4, the rest you don't need them. Okay. Okay, I'm even tired. So here what do we do now? We are exploring, right? Like I said here. So we'll put whichever you can put up or down, it still doesn't matter. Still get the same value. Okay. Still those same rules applies. 1 plus 1 is 0. 0 plus 1 is 1. 0 plus 0 is 0. So 1 plus 0, 1. 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 1 plus 0, 1 is 0, 0. Like that. Okay. Then again we convert this back into hexadecimal. So we get this back here. Okay. So we convert this back into hexadecimal. Okay, let me start by this. So yeah, we put these values. I copy these as well. Okay. something like this. So what do we have here? Easy. So what do we have here? Here we have this will be 15, so that will be F. Then this will be 8 plus this will be C, like this. So we'll get what is known again new state array. We're creating another new state array. So we have created one first box here. So you have to, and where is it? So come on. Oh, it is here. So the simpler part about why I like the stage 4 part is there's nothing like you are multiplying or doing. So this one will be added with this one here. This one will be added with this one. This one will be added with this one. And this one will be added with this one, just like that. That's the good part about stage 4, which is the add round key. Okay, so no stress, just adding. So this is total so far what you have. So we have created a new state array, and this is around 0 out of 16. So you have to repeat everything up to 16. So this new state array to be matched with this again, the S box here. You match it with the S box. You do the shift. The shift columns there. Then mix column, add round key. Again, you get back this. So do it how many times? 16 or 16 times, because this is just round 0. So I remain with 15 more rounds. So we cannot achieve all that. It's too much. So let's go to get this one with this one. This is the last one that I cut the video from here. Yeah. So we have so we need this again. X to binary. This table here. We need it back here again down. So this was what we have C2 and 116. So C2 and 116. 116. Okay. So what? Remember C2 is what? 12, right? So what number do you need to make 12? We have 8, 4. That's all. Don't need 2. Don't need 1. What number do you need to make 2? Don't need 8. Don't need 4. We need 2. Don't need 1. Okay. Then to make to make 11, we need 8. Yes. We don't need 4. We need 2 and 1. So 8 plus 2, 10 plus 1, 11. Okay. To make 6, we don't need 8. We need 4. We need 2. We don't need 1. Something like this. Now let's close this. So get this like that. This one here. So as usual, 1 plus 1 it's 0. 0 plus 1 is 1. Oh, 1 plus 1 is 0. 0 plus 1 is 1. 0 plus 1. 0 plus 1. 0. 1. 0. 0. This into hexadecimal. Now you might be feeling really tired. You think I'm feeling right now. Ish, Jesus of Nazareth, help us all. Okay, so again, now what we're doing, you're just converting. So what number is this? Here we have 4 plus 2 plus 1, which is 7. Then here we have just 4, which is 74. So down here just put 74. Remember, this also supposed to be filled up like this. Okay, so since we didn't fill up, so once you fill up everything here, all these zeros will be replaced with those values after I fill up. So I just want us to end this with the video on this one. So, and I know we might be concerned about the T. Remember the message was attack from front, right? Then this was solving doesn't include T, right? So for T, you do it separate as well. The same procedures that we have been doing, you just do it separate for T as well. Add this same round key. That's all. Oh yeah, add this same round key here, which is this. That's all. Yeah, I hope you have learned something. Yes, so if there are any questions, leave them in the comment section. I will try to attend to some. I'll try to attend to it. Thank you for watching. Don't forget to subscribe. This is Aaron or Mark or Ron Brown, whichever you prefer. Thank you for watching this video.